Hello, this is video 1 for CS3, also known as Computer Science 2444, and if I sound depressed, that's because I've given into my weaknesses. I wasn't going to talk about Program 1, but I just can't help myself. I'm weak and backsliding, and there's just too many juicy pictures to draw and talk about here. And this will be a good review. I mean, it's a review of watching me draw pictures at the whiteboard, if nothing else. You will recall, I hope you will recall, from your vast expertise in linked list construction, that the linked list that we did for CS2 had a head pointer, a cursor pointer, and a tail. Head, cursor, tail. Think fast. Class invariance. Head always points at an empty head node over here. It's actually not empty. It's got garbage in it. There's no reason to empty it out because we're never going to try to access the data field of that. The cursor always points to some node in the list. We don't even care which. It could be the first, it could be the last, it could be the middle, it could be anything. Tail always points at the absolute last, and the tail pointer next is always 0. There, quick review. Now then, what does that have to do with us? In Program 1, the insert operation is going to be different. It will insert at cursor arrow next, which means if we're going to make it different at all, then we're going to have to change where the cursor is. That's the big difference between the linked list that you already have and the ordered list that you will use your linked list to construct. So let's say that the list already exists. All of this is going to be one big before picture, and then I'm going to butcher it into an after picture. Let's say that these were already inserted. They weren't necessarily inserted in this order. I might have inserted Darby last or middle or whatever, but she's going to be at the front of the list because that's the smallest string alphabetically. Darby then points at Leo. Leo, and I'm drawing these so big, I'm not going to have room on my tiny whiteboard. Leo points at Solomon. I'll have to abbreviate that. Sorry, Solomon. And Solomon points at Trout. And that's the largest of the strings I've inserted alphabetically. So Trout will be at the end, have a 0 pointer, and the cursor, don't care, points anywhere. We'll let cursor point at Solomon since he got his name abbreviated. Payback. And quick review, head points at the empty head node. Cursor points at some pointer. It doesn't really matter with respect to violating or not violating class invariance. As long as it points somewhere, it's fine. And the tail pointer always points at the very last node in the list. Now, let's switch colors because we're about to change things here, and I'm going to hope this blue works. We want to insert Michael. Let's pause and reflect on that for just a second. This is me reflecting. If we insert Michael and we use that good old bulletproof linked list that we worked so long and so hard on, then where will Michael go? Well, if we just insert right now, then Michael is going to get squozed between Solomon and Trout. Excuse me, squeezed. Squozed is not technically a word. Michael would end up between Solomon and Trout, and voila, all of a sudden, we violated about the only new class invariant we'll have, which is the list contents are kept in alphabetical order. So we can't do that. We don't want to violate no class invariant, otherwise it's not even an ordered list at all, is it? So, oh no, what can we do? The cursor's in the wrong place. We could just return false. Say, I'm not going to insert Michael. No. We wouldn't do that. We would return false if we tried to insert Darby, or if we tried to insert Solomon, or if we insert Leo. The only time our new version of insert is going to return false is when the string that we're trying to insert is an exact match for something that's already in the list. In other words, another way to put it is we're just disallowing duplicate data items to go in our ordered list. No can do. Now, we can look into the future, ever so slight future, and see that yes, Michael is going to go in this list somewhere. We don't officially know yet. So, and I'm not even going to pseudocode the steps or anything. This is purely a picture drawing video. So I'm going to need a new node, probably with a temp pointer, allocate a new node. Been there, done that. And put Michael in the new node. And it's tiny a little bit inefficient, but if you want to, you can go ahead and put 0 as the next pointer. It's probably not going to be that when the smoke clears. But for now, that's okay. And let's think about this. This is me thinking. You've seen me reflecting. How do I look different when I'm thinking? Where does Michael go in the list? Okay, I can't help it. I'm going to cheat. I'm going to figure out where Michael goes in the list. Michael, no, I can't. I can't think alphabetically. I'm sorry. I take that back. The cursor is going to have to move, isn't it? Why? The cursor can only go on a one-way trip. All these pointers in our singly, emphasis on the singly, all the pointers in the singly linked list only point in one direction to the right. That's getting greater and greater and greater in the order list. So that's not good. So the cursor pointer at the moment, that's no good. And rather than mark that out and hopelessly mess up my picture, I'm going to erase it because we're going to move the cursor. Where should we move the cursor? Well, we could say move to tail. Allow me to insult your intelligence for a moment, okay? We could set the cursor to tail and insert Michael at the end. No. Well, maybe if this had been Z Michael. This is not Z Michael. This is the American Michael, not the French one. So Michael does not go at the end of the list. It goes somewhere back here. So we've got to get back here. If I recall, we only have one member function, only one mutator that's going to bring the cursor back here. And you are exactly right. We've got to call move to head back here, like so, and point cursor to the empty head node. Now all of this is happening before we've even decided. I jumped the gun. We don't even know yet whether we're going to return true or false. At this point, we officially do not know whether or not Michael is in the list or not. Here's another thing we don't know. We are an ordered list member function, and we have a variable, we have a private variable of type S list. We do not have private variables of type head, cursor, tail, or nodes, or anything like that. In other words, we're going to have to build this ship in a bottle with some chopsticks or something. I can call, what I mean by that is, what a ridiculous metaphor. What I mean by that is, I can call slist dot move to front, or whatever that was called. I think that's what it was called. S dot move to front, to move the cursor to the front in my underlying, one level down, in my underlying linked list. And know, because this was implemented correctly, that that will happen. So we secretly know that the cursor is now pointing at the empty head node. I cannot say s dot cursor equals s dot head. I don't get access to the private variables, even though that is my own private linked list variable inside my ordered list private variable section. I still don't have access to the private variables underneath the surface. That's what I mean by I'm going to have to do this indirectly. I'm going to have to do this by calling member functions on the linked list object. And I just did. I called s dot move to front. Good grief. What was that word I couldn't remember yesterday? Consultant. I got it instantly today. Maybe the caffeine is working. Okay. Now, we called move to the front. Now we're ready to insert Michael. No. Michael doesn't go at the beginning of the list. And I might as well make this lowercase like all the others. I just now noticed that. Michael doesn't go at the front of the list because Michael is greater than Darby, where if you're comparing strings, it's the order that they would show up in your phone numbers list on your phone or in a phone book if you're really old school. Alphabetical order, the order that these names would show up in a dictionary. Michael's going to come after Darby in the dictionary. So how do I even test? Well, here's a member function again. I would call s.get and get whatever is in that first node in the list. Now that I have it, I can take a look at it. And I can see if Michael, let's see, what test do I want to do? If Michael is equal to Darby, then we can get the heck out of Dodge. If I call get and get something that's equal to Michael, I can return false immediately and be done. No more thinking, no more talking, no more picture drawing. Do you see why that's the case? We don't allow duplicates. So now, I just now got Darby. Take a look at Darby. Darby's not equal to Michael, so I'm still here. So if I'm still here, now I have to decide, is this where I need to insert Michael or not? And here's a quick check. Michael, the new one that I'm inserting, that's greater than Darby. So I do not call insert on my linked list underneath the surface right away. What do I do instead? Exactly right. I call move and move the cursor. Now the cursor points at Darby. Now I do it all over again. Oh, if only there were some way in C++ to do something all over again. We'll have to look into that. Maybe do some extensive research online. The cursor points at Darby, and I call get. It's not going to get Darby. It's going to get cursor arrow next, and the get this time will give me Leo. Do my quick check. Can I get out of here without doing any more work, please? Nope, Leo and Michael are not equal to each other, so I don't get to return false immediately. So what do? I check to see if what? If Michael is, there's more than one check, and here goes that memory again. I don't remember if I checked if it's greater than, checked if it's equal to, or whatever. Oh, let's see. When will it go here? Michael will only be inserted at this point if it is less than what I just now got. I know they're not equal, or I'm gone already. I've already returned false. But if I compare and find out that Michael is less than Leo, then I'm in business. But Michael is not less than Leo. I am not in business. I'm closed for coronavirus. So I'm going to have to go through again. Michael's not less than Leo, so move the cursor again. Now cursor points at Leo. You got all this? If you're trying to formulate this in your mind or on paper into pseudocode and you just can't do it, that's what office hours are for. Because this video wasn't even going to be made, if you remember. So if you have trouble figuring out the logic based on this, let's do an office meet chat, shall we? I'll make myself a cup of coffee. You can get yourself an energy drink, and away we'll go. Here we go. Cursor points at Leo. We'll call get. We'll get Solomon. Quick check. Is Michael equal to Solomon? Nope. No return false. Still here. Quick check. Is Michael less than Solomon? Ding, ding, ding. We have a winner. Look. Michael is less than Solomon. Isn't Michael less than Solomon? By weight, alphabetically, just about every other way you can think of. Age, a lot younger than Solomon. So what do? Oh no, we can't access the cursor. Wah. We can't even access the node pointers or anything. How about this? How about we just call insert on our linked list? We've got an insert operation already. We call the insert in the linked list class. We're inside the insert function for the ordered list class. It's got to turn around at this point and call insert on its slist variable from the private variable section. And I won't even trace through that. I mean, I don't have to. I trust and believe in my insert function. And I believe that when it's done, then this arrow will be gone, and Leo will point at Michael, and Michael won't have a 0 next pointer. It will now point at Solomon. And if I call insert at all, that means I found the place where it was supposed to go, and I put it in there, and now I'm ready to return true. No more looping, no more moving, no more testing, no more nothing. I'm gone. I'm out of here. I'm done. I've finished program 1. Now, that's the general case. And lest I steal all of your fun, here's some thoughts. What if I were inserting zebra? What's that going to do? What if I get wild and crazy and name my dog Arnie? A-R-N-I-E. What's that going to do? We've discussed it already. What if I try to insert Leo? What's that going to do? So yeah, there's still fun stuff for you to figure out. But this is the general case. This is the general case of your primary and almost only modification of the operations that we already have for your ordered list. Now again, this is layered here. We've got an S list that is undisturbed. It is perfect, by the way. Your working linked list is perfect. I meant to tell you when you took CS2. I'm sorry for the delay. S list is perfect. Don't touch that. Don't make that do this. You've got a linked list variable now that's sitting inside your ordered list class. All this is done indirectly, the chopsticks and the bottle with the boat and all that stuff. All this is done indirectly by calling member functions on your private linked list variable. The get and the insert and all that. So it's making the underlying linked list do all the big work with the pointers and everything. You don't even really use any pointers in this at all. How could I call that a review? I just now thought of that. I'll have to dream up some way for you to have to use pointers. Nah, not for program 1. Okay, if there are questions, come by during office hours. I'm about to stop rambling. You're welcome, and I'll see you online.